Hey everybody, hope you're doing well. If you're watching this, that means you're at the end of week 4 of the 4th marking period. We're going to continue here with our factoring strategies. This video is going to take you through the third of 4 factoring strategies that you're going to learn in this unit. So today what we're going to look at is how to factor binomials using the difference of squares strategy. So just to briefly review, binomial means two terms. So everything we're going to look at today has only two terms to it, but it's going to have a specific pattern to it known as difference of squares. It basically is what it sounds like. Difference means subtraction. Squares, these are numbers that, or variables that are perfect squares. That's what we're going to be dealing with here. So numbers that can be easily square rooted, variables that can be easily square rooted and broken apart. So in order to factor apart binomials using this, it has to meet both those stipulations. Both terms must be perfect squares, easily square rootable, and they must be subtracted. So the formatting you're going to look at here. If given a binomial that is something squared minus something else squared, so a squared minus b squared, the way that it's going to break apart is you square root each of the terms. You'll see the same terms in both sets of parentheses. One gets added, one gets subtracted. The reason why the signs have to be different is because ultimately, like I've referenced in several of the other videos, opposite of factoring is to distribute. If I distribute them back together, that'll cause, when I multiply everything back together, the middle term that doesn't seem to exist, that'll cause it to cancel out. That's why the signs have to be opposite. This is a pretty simple strategy. It doesn't take a ton of guesswork here. It does help if you know your perfect squares a little bit, but ultimately, if I'm telling you explicitly to use this strategy, if you're not great with your perfect squares, your calculator will be very good at handling your square rooting needs. So let's go ahead and talk through. I believe there are 8 examples that we're going to walk through here, and we'll talk about this pattern here a bunch of ways. So, again, must be two terms being subtracted that are both perfect squares. So, x squared minus 100. I see a minus sign. That's cool. That's check number 1. Now let's talk about the x squared and the 100. Are those perfect squares? Well, x squared, if I square root that, that becomes x and x. That's the first thing. 100, is that a perfect square? If I take the square root of 100, that is 10. One thing, remember, square rooting is not dividing by 2. Please do not cut these numbers in half. That is very, very wrong. It's a common mistake that some people make. Please don't make that mistake. Square rooting is a different type of math. So, we're subtracting. Both terms are square rootable. Then we split this apart. So, x squared becomes x and x. 100 square roots of the 10 and 10. 1 gets added. 1 gets subtracted. And this is now factored apart. Remember, it does not matter which order you write your factors in, so you could write it as x plus 10, x minus 10. You could also write it the opposite way, where the minus comes before the plus. They both mean the exact same thing. I don't care what order you write them in. They're both correct. Know that, again, if you see this in different ways here, that you might see the order different. If you write plus then minus, I might write a minus then plus. It doesn't matter which way you go, as long as you have one of each sign for your factors. That's all there is to this strategy, though. If you can take some square roots, this is a pretty easy strategy to work through. So, let's take a look at number 2. Same idea, x squared minus 169. I see subtraction. That's good. Now I'm going to split apart. X squared becomes x and x. 169 is a perfect square. If I square root that, that becomes 13. 1 gets added. 1 gets subtracted. And my final answer, x plus 13 times x minus 13. Again, you want to hit the pause button here. Try number 3. See if you get what I get. Let's talk about 3. I see a minus sign. Cool. We know by this point x squared becomes x and x. 289, that is a perfect square. The square root of 289 is 17. 1 plus, 1 minus, and all done. Now let's talk about 4. 4 is x squared plus 36. I emphasize the plus because all the other problems so far have been minuses. This is called a difference of squares. If I see the plus sign, that would act like it's a sum of squares. This does not actually factor apart. This is not a factorable problem, and I'm going to explain why. So what could be tempting is, well, you see x and 36, and say, well, okay, we know x squared is x and x. 36 becomes 6 and 6. Well, let's do this here. Let's say I just use the pattern from up above, and I just ignore the fact that there was a plus sign of the problem. Again, this is not correct work, okay, so follow me here and listen for a minute and watch the work here. Keep in mind, if I were to check this problem, I would distribute it back together. So I get x squared minus 6x plus 6x minus 36. These two terms cancel in the middle, and look what I'm left with, x squared minus 36. Well, my problem is x squared plus 36. So that didn't match. Okay. Well, let me play with the signs here. What if they were both addition? Okay. So again, I distribute. I get x squared plus 6x plus 6x plus 36. Now I get x squared plus 12x plus 36. Well, that didn't match. That's still a problem. Well, the only other combination of signs I haven't tried is if they are both minuses, subtraction signs. All right, let's do the same thing. X squared minus 6x minus 6x plus 36. Well, if I combine the like terms in the middle, I get negative 12x again. Well, again, it doesn't match. That's also a problem. Okay? So, no matter how I play with the signs, even if I decide to go off my own pattern here, I can't break x squared minus 36 apart. That's a problem. So, be very careful. If you see a problem like this, it's not necessarily, I mean, I guess in a way, it's tricky because it looks something very similar, but there's just one change of sign here. It is called a difference of squares pattern for a reason. It has to be a difference of the two terms. The fact that it's a plus sign, there is no sum of squares. Okay? I'm going to put that in quotations because this does not exist. Sum of squares is not a factoring pattern. It will never work. Anything that is x squared plus something else that's square rootable, it is never going to work. Therefore, this is not factorable. So I did just kind of want to throw that in there, just because it is a detail that you do need to pay attention to. Again, not saying you're going to come across this very much, but once we get about another week or so into this, when we do problems that require you to factor completely, which is a way basically of using all your factoring strategies possibly at once, you do want to watch your signs to make sure you don't split apart something that can't be split apart. So again, they have to be subtracted. They both have to be perfect squares. If either of those is not true, it's not going to break apart correctly. So just something to keep in mind. All right, let's continue here with these last four examples. The only difference now is it's not just an x squared. There's now a number in front of the x squared. Maybe I threw another variable in. It's all the same thing. So we see for all four problems, we see minus signs, we see two terms. That part's established. Let's talk about square rooting each of these guys apart. So 9x squared, the square root of 9x squared is 3x. Okay, square root of 9 is 3. X squared turns into x and x. Square root of 25 is 5. One gets a plus, one gets a minus. So factors apart is 3x plus 5, 3x minus 5. Number 6, same idea. 64x squared, that becomes 8x and 8x. 9 becomes 3 and 3. One gets a plus, one gets a minus. 8x plus 3, 8x minus 3 are your factors. 7, I've got 121x squared minus y squared. 121x squared becomes 11x and 11x. Y squared is just y and y. Plus, minus, 11x plus y, 11x minus y. And last but not least, number 8, 225x squared minus 324y squared. 225x squared, 15x, and 15x. 324y squared is 18y. 18y. One gets a plus, one gets a minus. And we're going to leave that as 15x plus 18y times 15x minus 18y. So, that's how you do the difference of squares factoring pattern. Again, it's a very specific one, and you'll be able to recognize when you need to use it pretty quickly because, again, you're only doing this with expressions that are binomials, two terms, being subtracted, have to be square rootable, and there's only so many numbers that absolutely do that. So, pretty short lesson here. Hopefully you figured out the pattern pretty quickly. Your graded assignment with this one's going to be slightly different just because there's not really a lot of work that you can show for this. I made a little quick Schoology quiz of it, so when you look in the folder for this, you'll see something that says complete the assignment here. It'll just take you to what I believe is an 8-question quiz, questions that are very similar to these. Always want to make sure that you realize is the answers are pretty similar to each other on purpose, so it's not completely obvious which is the correct answer. So please make sure you take your time, select the correct answer, pay attention to signs, pay attention to things being square rooted properly, etc. Should hopefully be pretty easy though, as long as you are taking your time and reading each question and set of answers. So again, if you have any questions with this in particular, please send me a Schoology message, shoot me an email, or get a hold of me on my office hours on Zoom, and I'll be more than happy to help you with anything you need. Otherwise, if you're good with this, stay safe, stay healthy, and as always, thanks for watching.